Hello everyone, let's go ahead and take a look at interpolation and extrapolation. Now, when we're dealing with correlation, again, remember we wanted to find the line of best fit, and we did that using a linear regression model. Now let's go ahead and assume that we have a particular data set. The first variable is x, the second variable is y, and let's assume also that our correlation is strong. Okay, so this is basically what we have here. Now, the thing is that we should be able to make some generalizations about data that is no longer part of the original data set, but is introduced to this particular scatter graph. So say, for example, if I wanted to go ahead and say that a particular value of x was 4, would I be able to make some generalizations about where the value of y would be? If I had a value of 0 for x, would I be able to make some generalizations about where the value of y would be for that particular x value? And the answer is yes and no. It depends. Let's go ahead and see why. Now, when we go ahead and talk a lot about interpolation and extrapolation, let's make sure that we are very clear about what we're referring to. Now, the part that you need to be careful, pay attention to with regards to these two terms is the pole in interpolation and extrapolation. Because basically, interpolation is between the poles, and extrapolation is beyond the poles. Now the question is where are the poles? If we go ahead and take a look at our original data set, if we take a look at the extreme values of our data set, those then would be considered the poles. So in this particular case here, it is the value of A, and it's also the value of B. So what we have then is we have interpolation is going to be any particular x value that is going to be between the x value of b and a. Extrapolation, on the other hand, is going to be any x value that is less than the x value of b or greater than the x value of a. Now, again, let's go ahead and take a look at this. If our correlation is strong, then we can make generalizations about the data not in the given data set. So if I go ahead and give you a data set, another new particular value of x, say 4. What I'm doing right now is I'm extrapolating based upon the given data that I have. If I choose a value of 0, then I'm interpolating, okay, the new data value, given that we are between the poles. Now, take a look at this. If our correlation is strong, then interpolation actually has a very high reliability. Extrapolation has less reliability. Now, why is that? Because we said that our correlation is strong. Now, this is the reason for it. If we go ahead and take a look at what's interpolated, if we try to interpolate, which means that we're actually introducing a new value between these two extremes here, then notice that it's actually going to be within the given data. Is going to be a value, the x value is actually going to be an x value that's already within the given extremes of the given data set. And therefore we would expect that the correlation would still be very strong. And being that the correlation is still very strong, then we know that our line of best fit should be able to go ahead and give us a best generalization of what we think the new value of y would be for that new value of x. Now, why does extrapolation, on the other hand, have less reliability? Well, the reason for that is because if we go beyond the poles, who knows what happens out here with regards to who knows what happens beyond these values? What we know is that our correlation is based upon what is between the poles, not what's beyond it. And who knows what's happening out here? And we also have different types of regression models that could then go ahead and tell us that the value should be all the way up here as opposed to the linear regression, which would tell us that the value should be closer to that. So notice that our correlation is based upon the values that are between the poles, and therefore we have high reliability if our correlation is strong. If we try to extrapolate, we need to be very careful. There's less reliability because our correlation was not determined by any of those values beyond the poles. Okay, so there you go. That's what interpolation and extrapolation is all about. We need to be careful about looking at the poles and determine whether we're dealing with interpolation or extrapolation. And remember that even if our correlation is strong, we need to be careful about the reliability. There's higher reliability with interpolation and less reliability with extrapolation. So if we have any questions about that, we'll go ahead and talk about that the next time that we see each other in class. See you then. Bye-bye.